So we just went over in the Fundamental Theorem of Calculus, Part 1, and so it says that if you have this this function g of x, then you know that g prime is just f of t. In other words, g is an antiderivative of this little f. And so let's take a moment and look at this problem. So if I want to take the derivative of this function, the function that computes the area from 10 to x of sine cubed of t dt, the derivative of this is just sine cubed, we usually write, of x, not t, because the function, the overall function, is a function of x, not of t. The t's here are just to avoid variable confusion. So that's that. Second example, if I want to take the derivative with respect to x of the integral from 1 to 2 of t cubed, this is going to be a number. It may not be area if t cubed dips below the x-axis. It doesn't, though. T cubed is positive on 1 to 2, so this is just the area under t cubed from 1 to 2. That's a constant, and the derivative of a constant, you know, is 0. Done with that one. Example 3. Let me give us a little more space. So we want to find the derivative of g given this g. And so again, at a glance, I'm going from 0 to x, and I'm integrating this function, so I know that without working too hard, g prime of x is just the sinh of x cubed plus 5. Done. That's all there is to that one. Now, of course, I'm going to complicate things slightly. So what am I going to do? Oh my, I'm going to throw in a twist here. Instead of having just an x upstairs, what happens if you have something else? Like in this example, I have an x squared upstairs. Let's switch to yellows. So what do? Well, you need to view this as function composition and then use the chain rule. So you can actually view this, if you want, as the integral from 0 to x of sine of t dt composed with x squared, because that's what you're doing. You're plugging x squared into this function, and that's what's going right there. So now let's think through the chain rule. The chain rule says take the derivative of the outside function, plug in the inside, and then multiply by the derivative of the inside. So the derivative of the outside function is sine of sine of x. So this derivative is sine of x. Plug in the inside, so I get a sine of x squared. Then I multiply by the derivative of the inside, which is 2x. And so I would write this as, sorry, this should be g prime. G prime is going to be 2x sine of x squared. So I'd like you to pause the video and you do this one. See if you can work out problem 5 yourself. And then, I need to close that so we have a little more screen space. Pause the video and see if you can get it. Okay, so like last time, I'm realizing that the outside function is the integral from 0 to x of t cubed dt. So I know that I'm just going to get the derivative of the outside is just x cubed, plug in sine, so I get a sine cubed x times the derivative of sine is cosine of x. So in other words, there is a pattern here. You just plug whatever this is into this expression and then multiply by the derivative of this. That's how this boils down every time. I would like you to understand, though, that we're using the chain rule inside-outside formula. So one more example. Please pause the video, work this one out yourself. You should get, for the derivative, g prime of x is going to be the sine of 3x squared plus 5 times 6x, and I'll just leave it like that. So I'll pause this video here, and in the next video we're going to see the Fundamental Theorem of Calculus Part 2. There's more, and I'm excited to show you.